Good morning, it's Thursday the 4th of June. Right, so I'm going to start off by doing a couple of questions that I gave you for today. So the first one is y is equal to x cubed minus 3x squared. And three things we've got to do. We've got to find out where it cuts the y-axis, and then find out where it cuts the x-axis, and then find the stationary points. So first thing you do, and get in the habit of doing it, is you make your statement. So it cuts the y-axis when x is equal to 0. Right, so we'll make x equal to 0. So y is equal to 0 to the power of 3 minus 3 times 0 squared. And that, of course, comes out to be 0. So it cuts the y-axis at the origin, which is the point 0, 0. Right, so cuts the x-axis. It cuts the x-axis when y is equal to 0. So this is the one that's always a wee bit harder because it cuts in more than one place. So y is 0, so 0 is equal to x cubed minus 3x squared. I'm going to write it round the other way. So x cubed minus 3x squared is equal to 0. Key word to solve anything like that, where you've got squared terms or to the power of 3 or anything else, is you factorise. So highest common factor is x squared. So in your bracket you will have x minus 3, and that's equal to 0. So product of two things that multiply to give me 0. So either x squared equals 0 or x minus 3 equals 0. So if x squared equals 0, x is equal to 0. And if x minus 3 equals 0, then x is equal to 3. So two places where it cuts the x-axis is the point 0, 0, and the other point is 3, 0. Right, so the third thing is we've got to find out where the stationary points are. So stationary points occur when dy by dx is equal to 0. Right, so we want to find dy by dx. So y is equal to x to the power of 3 minus 3x squared. So dy by dx will be equal to 3x squared minus 6x. Right, so we want to make that equal to 0, so I'll write it over here. So 3x squared minus 6x equals 0. Highest common factor is 3x, so that leaves x minus 2 in the bracket. Right, so either 3x equals 0 or x minus 2 equals 0. If 3 times x is 0, then x must be equal to 0 divided by 3, which is still 0. Add 2 onto both sides, so x is equal to 2. So we've got two stationary points on this curve. We've got the point 0 something, and I know 0, 0 lies in that curve. So I've got the point 0, 0. And the other point I have is the point 2 something. Now I need to work out what the y coordinate is. So the y coordinate is equal to, y is equal to x to the power of 3, so it's 2 to the power of 3 minus 3 times 2 to the power of 2. So 2 to the power of 3 is 8, minus 2 squared is 4, 3 fours are 12, 8 take away 12 is minus 4. Right, so there is two stationary points. Okay, right, next thing we need to do is find out the nature of these stationary points. So start off with your nature table. Draw your lines. So we've got two turning points, so make that two sections there. X goes at the top. First stationary point with the lowest x number is 0, and the next one is 2, and it's important you get them in order. Right, you're looking at the graph. 0, 1 is to the left of the 2. Right, so we want to know what's happening before, what's happening after, what's happening before, and what's happening after. Right, now we need to put in the y by dx to find out what the value is, whether it's positive or negative for the stationary point. So dy by dx is equal to, and the derivative is 3x squared minus 6x. So 3x squared minus 6x. Right, we know at our stationary points dy by dx is 0, so I can put 0 in there and I can put 0 in there. Right, a value less than 0, we'll pick minus 1. A value between 0 and 2, so we can pick 1, that's easy enough. And a value bigger than 2, we'll pick 3. So when x is minus 1, if I work out dy by dx, and I'll write it underneath here, so dy by dx would be 3 times minus 1 squared minus 6 times minus 1, which is 1 times 3 is 3 plus 6, so it's 9, so it's positive. Okay, don't need the number, I just need to know whether it's positive or negative. Next one I need to do is when x is equal to 1. So dy by dx when x is equal to 1 is 3 times 1 squared minus 6 times 1. So that will be 3 minus 6. That is going to be negative. So that will be the same. And we'll do dy by dx when x is 3. So dy by dx would be equal to 3 times 3 squared minus 6 times 3. 3 squared is 9. 3 nines are 27 minus 18. And that's going to be positive. Okay, I'll take that out so I can put the shape in. So what I've got then is, I have got positive, 0, negative, negative, 0, positive. So I've got a maximum turning point, and that maximum turning point is at the point 0, 0. And I've got a minimum turning point, going like that, and that minimum point is at the point 2, and I think it was minus 4, 2 plus 4, sorry. Okay, right, now we need to sketch it. Okay, so for that one, it's all worked out as that. Now, I've got a confession to make. You cannot draw that one because I copied down the wrong power up here. Okay, so all the working is correct. That's okay. Right, you can still do that. You can still do that. And you can still work out stationary points, but you cannot draw it. Okay. Right, so next one was y is equal to x cubed bracket 4 minus x. Now sometimes they give you something like that that's already factorised. Right, that's okay. We want to find where it cuts the y-axis, so that's when x equals 0. So when x is 0, I've got 0 cubed times 4 minus 0. So 0 cubed times 4 minus 0, which is obviously 0, so it cuts at the point 0, 0, the origin. Right, where it cuts the x-axis, and this is where it's already factorised for these, don't multiply out the bracket. So when x is nothing, we'll get x to the power of 3 times 4 minus x is equal to 0. So either x to the power of 3 equals 0, or 4 minus x equals 0. That would give you x equal to 0, and that would give you x equal to 4. Right, so it's cutting at 2 points, it's cutting at the point 0, 0, and it's cutting at the point 4, 0. Okay, and 3 to the power of 4, 3 3s are 9, 3 9s are 27, 3 27s are 81. Right, so when I take those two values away, then I get 108 take away 81 is going to leave me with 27. Okay, it's quite a big number there, but that's okay. Right, so I've got the coordinates of my two stationary points. Now I want to get the nature. So draw your nature table. Nature table, we've got two stationary points, so split it into 2. That's your x numbers, that's dy by dx. And we've got two stationary points, one at 0 and one at 3. So 0 and 3, going towards 0, going away from 0, going towards 3, going away from 3. And stationary points, the derivative is 0. Derivative is 0, and the equation for the derivative is that one there, which was 12x squared minus 4x cubed. So it's 12x squared minus 4x cubed. Okay, so pick a value less than 0, so minus 1 would fit in there. Pick a value between 0 and 3, so just pick 1, make it the easiest one. We could have 1 or 2. And then there we'll pick 4. So when x is equal to minus 1, dy by dx is equal to 12 times minus 1 all squared minus 4 times minus 1 to the power of 3. So that gives us squared is positive, so that gives me 12. That's going to be negative 1, so negative 1 times negative 4 is plus 4. So it's going to be 16, so that gives me a positive value in there. Okay, so next one is when x is equal to 1, so that would be 12 times 1 squared minus 4 times 1 to the power of 3. 12 times 1 squared is 12, 4 times 1 cubed is minus 4, so it's 8, so that's also positive, and that will be positive. Right, then we have to do when x is 4, so when x is 4, I've got 12 times 4 squared minus 4 times 4 to the power of 3. So 12 times, that's going to be 4 fours are 16, so 12 times 16 minus 4 to the power of 3, 4 to the power of 3, 4 fours are 16, 4 16s are 64. So 192 minus 256, that's obviously going to be negative. Okay, so therefore, if I do the shape, I have got an uphill, I've got a cross, and I've got an uphill. So I've got a point of inflection, and the point of inflection was at the point 0, 0, the origin. And then I've got uphill, across, and downhill. I've got a maximum turning point at the point 3, and I think it was 27, yep, 327. Right, so if we do a wee sketch of that one, so draw your x and y axis. So there's your y-axis, there's your x-axis, and if I write down the points where it crossed the axis, so it crossed the y-axis at 0, 0, and we've got 0, 0 and 4, 0. So origin is 0, and then we've got the point here, which is 4, that's where it crossed the axis. Now I've got a point of inflection sitting at the origin, so the point of inflection looks like that. It comes up and it curves, and then it curves round again. Now it's coming up to a turning point at 327, so take it right the way up, turn it round, and bring it down through that point 4. And it's supposed to be symmetrical, but I can't draw. Right, so that's 327. Okay, so all points are annotated. That's the point 4. Okay, I've drawn through it, so that's 4, that's the origin, and that's 327. Right, sorry about the last one that you couldn't draw it. I'm going to give you another few of these to do. The next lot are a wee bit longer, so I'll give you a wee bit longer time to do them. Okay, so I've given you 4 curves to sketch. Okay, so you're going to sketch each of them. Okay, now you know they're long questions. So what I'll do is I'll give you them for Tuesday. Now that takes us to the end of this curve sketching. I'm going to do one other new bit to this differentiation, which is sketching the graph of a derivative. And after that, we'll go back and we'll revise, because you've done quite a lot of questions. Mr. McCutcheon is still putting up revision for you as well. Right, so he's liaising with me and he's putting up some extra questions for you to do, but you've got to look at my videos. So one other thing that's different after this, and then we will, between the two of us, we will do quite a lot of work over the next couple of weeks to make sure that you are secure in those 2 topics. Okay, right, so work hard.